5 minutes to learn all details of the fiber laser cutting head. Without further ado, let's get started. Have you ever wondered, among laser cutting machines of the same type, why do some produce mirror-smooth cut surfaces, while others end up with heavy burrs and serious slag adhesion? Why, at the same power level, do some machines cut quickly and stably, while others suffer from frequent slag clogging and burned lenses? The answer lies in a component that is often overlooked yet critically important: the laser cutting head. It is far more than just a light outlet. It is the core terminal actuator integrating optics, mechanics, electronics, and pneumatics. Why does it determine cutting accuracy, speed, surface quality, and overall machine stability? And how does it transform an invisible infrared beam into a high-energy blade that cuts through metal like butter? Next, we will take it apart layer by layer and reveal all the secrets of this light blade. Step 1. Core working principle. Can a laser beam cut steel plates directly as soon as its output from the laser? Absolutely not. Without precise control from the cutting head, even the most powerful laser is nothing but a scattered beam, incapable of effective cutting at all. Its workflow is nothing short of a micron-level energy magic show. First, the light enters the laser head and passes through the collimating lens first. When the laser is output from the laser, it exhibits slight divergence. If focused directly, this would result in a large, soft spot with dispersed energy, making precise cutting impossible. After passing through the collimating lens, the laser reaches the focusing lens. What happens when parallel light enters the focusing lens? It is instantly compressed into a micron-scale focal spot with a diameter of only 10100 m, and its energy density increases by tens of thousands of times. Just how powerful is such a tiny focal spot? It is powerful enough to melt and vaporize steel plates within milliseconds, achieving non-contact cutting. Coordinated auxiliary gas. A high-pressure auxiliary gas, oxygen, nitrogen, air, etc., is ejected synchronously from a nozzle coaxial with the laser beam. On one hand, it blows away molten or vaporized slag and fumes to prevent them from adhering to the cut surface. On the other hand, depending on the gas type, it provides supporting combustion oxygen for cutting carbon steel, antioxidation nitrogen for cutting stainless steel, or cooling air for thin sheet cutting. Dynamic tracking stability. Built-in sensors detect the workpiece surface height in real time and automatically adjust the cutting head position to ensure the focused laser spot remains at the optimal focal position on the material surface. Even for curved or uneven sheets, consistent and stable cutting quality is maintained. Next, let's take a step-by-step look at the key components of the laser cutting head. First is the fiber connector, located at the very top of the cutting head. It serves as the entrance for the laser beam to enter the cutting head. Its core function is to hold the transmission fiber in place and ensure precise alignment between the fiber and the internal optical path of the cutting head. Upper protective lens. Located directly below the fiber connector, it is the first lens that the laser comes into contact with when entering the cutting head, and also acts as the first protective barrier for the entire optical system. Its core functions are to filter fine impurities in the laser beam and block splashes of molten slag and smoke generated during the cutting process from bouncing back upwards. Collimating lens. Located directly below the upper protective lens, its core function is to correct the slightly divergent conical laser beam emitted from the optical fiber into a parallel beam with highly consistent direction and uniform energy distribution. Focus lens. Located directly below the lower protective lens, this is the core working component of the cutting head optical system, as well as the most expensive and precise part of the entire cutting head. It instantly compresses and converges the collimated parallel laser beam into an extremely small high-energy focal point with a diameter of only 10100 m, achieving highly concentrated laser energy. Lower protective lens. Rear protective lens. Located directly below the collimating lens, it serves as the second protective barrier of the optical system, further filtering residual fine impurities in the laser beam. Height sensor. Tracking sensor. Mounted on the middle side of the cutting head, it acts as the eyes of the cutting head. Its core function is to detect the distance between the cutting head and the plate surface in real time, providing signals for dynamic tracking to ensure the focal point remains at the optimal cutting position. Collision protection module. Mounted in the middle of the cutting head, it serves as a safety device to protect the cutting head. Its core function is to automatically trigger protection when the cutting head accidentally collides with workpieces, fixtures, or other obstacles, preventing damage to the expensive optical system and mechanical structure. Connecting pipelines. Auxiliary gas pipeline. As one of the most critical pipelines, it connects to the gas pressure stabilization module of the main unit and is responsible for delivering high-pressure auxiliary gas to the interior of the cutting head, which is finally ejected through the nozzle. Cooling water system, an indispensable core cooling component of the cutting head, specifically designed to cool precision internal parts such as the collimating lens, focusing lens, and ceramic body. Optical chamber protection air line. It supplies dry and clean compressed air to the cutting head optical chamber to create a slight positive pressure environment, preventing smoke and molten slag from contaminating the lenses. At the same time, it keeps the optical chamber dry to avoid lens fogging and condensation, thus extending the service life of the lenses. Signal control cable connects the host control system to the height sensor, electric focusing module, and collision protection module of the cutting head. It is responsible for transmitting control signals and detection signals to ensure the normal operation of all electric components of the cutting head. Finally, we come to the nozzle. Located at the very bottom of the cutting head, it serves as the outlet for both the laser beam and auxiliary gas. Positioned close to the sheet metal, it is a key component for achieving precise cutting and is also a consumable part. By now, do you still think the laser cutting head is just an insignificant accessory? It is the final executor of laser energy, accurately converting laser power into cutting force. It is the decisive component for cutting quality, directly determining machining accuracy and cut surface quality, and influencing product competitiveness. It is the last line of defense for equipment stability, reducing downtime and ensuring efficient production. From micron-level optical focusing to millisecond-level height tracking, from intelligent anti-collision design to long-term thermally stable operation, every detail of the cutting head design affects your processing efficiency, production costs, and product quality. Therefore, next time when purchasing or operating a laser cutting machine, don't just focus on laser power, check the cutting head first to see the real performance. Choose the right cutting head for easier and more reliable processing. Zoryar, your reliable business partner.